All right, let's get this going here today. Let's get this going. Again, calculator right next to you. Make sure you're in degree mode. Should be already, but just in case. All right, still going to do word problems today using sine, cosine, tangent. Still working with word problems. Instead, today, I'm going to add in 2 new vocabulary terms, right, that I want to talk about right now. 2 new vocabulary terms. And the easiest way, it is very, very tough to teach these 2 new vocabulary terms in the system we're in. Half you guys here, half you guys at home. All right, it's a lot better when everyone is here. So what I had to do this weekend is try to find you guys something that you could interact with. So you guys at home right now, I am going to put a link into the chat that I'd like you to go to this website so you can play around with this as well. And you guys here in class, you're going to have to watch me play around with it. All right. So let me put this link right here for everybody. All right, I'd like you to go to that for me, please, and wait for instructions as I get there myself. Okay, so hopefully you guys at home are getting to this website right now. What I'd like you to do first is up top where it says show label. Could you just click on that for me, please? Show label. All right, so here we go. We have 2 new terms today, 2 new terms. First term is called the angle of elevation. Angle of elevation. And here's what it is. You can see our little guy Johnson here poking his head out of, I don't know, a castle, some kind of platform, whatever. See how he's looking straight ahead? That's called his horizontal line of sight. All right, his horizontal line of sight. Now, he is about to look up at the airplane and form what is called our angle of elevation. All right, so right now he's just looking straight ahead and he sees an airplane above. So you guys at home, this little drop-down menu here, select the plane, please. Let Johnson look at the plane. Now everyone watch the angle that's about to happen. Everyone see that angle as he lifts his head to the plane. It is forming an angle with the horizontal line of sight he had originally. That angle is called your angle of elevation when you look up at something. And if you guys at home want to play around with the plane right now, make it go lower, higher, further out, you can see his angle of elevation changes. All right, but take a look what doesn't change is the other part of the angle, which is horizontal line of sight. Okay, so to everyone, we're all good. He started looking straight ahead, then he looks up at the airplane and makes this angle right here, which is called the angle of elevation. Do you see a right triangle that can be made out of this diagram? Everyone see a right triangle that can be made? If I just draw from the airplane vertically down to the horizontal, I can form a right triangle. And that's what we're going to do today. But I just want to let you guys see what the angle of elevation and how it's formed. Questions on angle of elevation as Johnson looks up to the plane. All right, so that's elevation when I look up. What if I'm already on like a top of a building and I look down on something? All right, so everybody at home now, he's going to be looking down at the yacht now. So he's still, let me put this back. He's still going to be looking straight ahead at the horizontal, but now everyone on your drop-down menu, click the yacht. Now, when he looks down, I form an angle called the angle of depression. All right, the angle of depression. Still formed by that horizontal line. Okay, still formed by the horizontal line. I should probably get the plane out of there. There you go. All right, still formed by the horizontal line. But now you're looking down at something. Okay? So looking up, I form this angle called the angle of elevation. Looking down, I have an angle of depression. Now, here's the one thing about depression. And if you guys at home want to keep playing around, go ahead. Here's the angle. Here's exactly what I just copied of what I had on the screen. I need you guys here to help me out. Do you see this right triangle that I formed here? We see that right triangle? Here's the problem, though. My angle of depression, it's not in there. So if I'm about to use sine, cosine, tangent, I can't use the angle of depression where it is right now because it's not inside my right triangle. So I'm just going to say, hey, let's say the angle of depression is 20 degrees. So Johnson's looking down at a 20-degree angle at the yacht. I can't use 20 though. I can't use that 20. It's not inside my right triangle. And it's got to be inside if you want to use sine, cosine, tangent. So before we do any problems using angle of depression, can you guys help me out? Is there any way I can use 20 degrees to get an angle inside my right triangle? Because where that 20 is right now, it's not going to help me. Can you use the 20 to get an angle inside my right triangle? Quincy?
Is it complementary to the top angle?
Okay, one way. The angle that's adjacent to it, they're complementary, forms a right angle. So instead of using this 20, I could put 70 inside and use 70 now as the sine, cosine, tangent angle. Did anybody see how else I could use the 20 instead? Radhika?
You can draw a different right triangle using like the line of sight and like the yacht and then the Johnson.
Okay, so you're saying use this instead, this triangle here? Okay, the only thing you want to be careful with is you may not know sides to that. Like I may know his height right here instead. So you're going to have to know, hey, I got to match that over here. So that's, yes, you can do that. Just be careful of your lengths. Okay? Anybody else see how else I could use the 20 to get it inside get an angle inside?
You could use, you could make it an all interior angle.
Alternate interior angles. Remember those from parallel lines? If that's 20 down here near the yacht, that's got to be 20 because those are alternate interior. Yes. So you guys decide when we get to an angle of depression problem coming up. Do you want to take the complementary angle adjacent to it and use it? Or do you want to use the alternate interior angle of 20? Your call. Okay, your call. Any questions for me, guys, as far as angle of depression or angle of elevation before you guys start drawing your own diagrams here? Go ahead, Sophia.
So is this only for things involving line of sight, or is that just an example?
This is, when I say elevation and depression or a problem says it, we're always going from one part of that angle is your horizontal line of sight. And then the other part is either looking up at an object for elevation or down on an object for depression. The horizontal is never going to change. All right, let's hop right into a problem now. Here you go. We got Scotty Bones here. All right, reminds me of some of the guys in this class. Pretty frail, huh? Too harsh, fellas? Sorry. Get over it. Truth hurts. All right, his eye level, 1.5 meters above the ground. 1.5 meters above the ground, Scotty's eye level. So basically, hey, his height, right? Is going right up to his eyes, 1.5 meters. He stands 30 meters from the tree. Let's put a 30 somewhere. He's standing 30 meters from a tree. So it's got 30 meters right here. All right, here's where we get into the vocabulary. The angle of elevation to the bird that's sitting on the top of a tree is 36. Remember how angle of elevation is formed. Remember Johnson looking up to the plane. Horizontal line of sight up to the object. That angle, 36 degrees. Everyone see how I made that angle? From his line of sight, horizontal line of sight, up to the object I'm looking at, 36 degrees. How far above the ground is the bird? So ground to bird. Here's what we're looking for. Ground to bird. All right, well, let's finish this drawing off. Let's make a right triangle because that's what we've been working with this entire unit. Let's make a right triangle out of this. All right, now I need your help. I see 36 degrees in there. Can anybody get a side length? Anybody know a side length or a side measure in that right triangle I have just drawn on my diagram? Anybody see one? Quincy, go.
30 meters.
30 meters right here. This horizontal leg is 30 meters. And do you see how using this triangle, I'm not going to find the distance from the ground to the bird, but I can get pretty close. I can find this leg right here, the vertical leg, and maybe do something to it at the end of the problem. All right, everyone see our plan? Let's find that leg. And to find the whole distance, I'm going to have to do something to that leg at the end. All right, I'm going to need your help now. 4, here we go. Not here. 8, here we go. Ryan, you're up. Going from my 36 degrees, Ryan, because I always go from the acute angle. What's the x in this diagram? Opposite, adjacent, hypotenuse?
Opposite.
Opposite. How about the 30?
Adjacent.
All right. Whether you use SOHCAHTOA, Ryan, or you memorize the ratios, which one uses opposite and adjacent sides?
Tangent.
Good job. Perfect. Good work, Ryan. Tangent of 36 equals, and I'm not asking anybody these questions anymore just because we should have this down pat. This is our 3rd day of doing this. Opposite side x over adjacent 30. Put it over 1 if you guys feel like you have to, and then cross multiply. Here we go. And remember, this is not your answer. So I don't want you to round. It is not your answer. I don't want you to round. Here's what I'm getting out of my calculator. I'm writing the full display down too. 21.79627 584. That's just from his horizontal line up to the bird. That's it. Now what are you suggesting I do to actually find the ground to the bird? What do I need to do with my 21 and change here? Here we go. Luke, going over to you, because that's not my total height, Luke. What do I still need to add on to it?
The 1.5.
Good, the 1.5, which is his eye level. Perfect. Then I can round, because this will be my final answer. .3 meters up to the bird. Any issues there? Go ahead.
So if you had an elevation or depression angle, if you had an angle that was 90 degrees, in that case, wouldn't you be looking straight up or straight down?
I get, but we're always coming from an angle though. That's not 90. We're always going to come from an acute angle. I can tell you that. Yep, we're always come from an acute angle. Other questions, comments? Okay, so there's elevation. Let's see what depression looks like now. Because I always think depression are the tougher ones. Angle of depression of 40, John watches his friend approach the building. So I know depression, somebody's looking down from a horizontal line of sight. So let me help you guys here. So here is his horizontal line of sight, and he's looking down on his friend at a 40-degree angle. Take a look. This is where the 40 degrees is, outside. All right, it's always formed from the horizontal looking down. So if you guys want to darken in your right triangle that we're going to be working with, might be a good idea. Here we go. And if you don't want to use that one, Radhika suggested earlier in class, you can draw this instead and do the other right triangle. It's up to you. All right, there's other parts I got to label though, right? That's not the only piece. The rooftop, 16 meters from the ground, so rooftop here. And his eye level is 1.8 from the rooftop. So there's 1.8 from the rooftop. What's the distance between John's friend and the building? All right, well, his friend's on the ground. The building's over here, so we're going to be looking for that. All right, you guys need to make a personal decision. I am not going to force you to make it, or we're not making a class decision here. What are you doing with the 40? Because you can't use it where it is right now. You're doing one of two things. You're either making it complementary with the angle adjacent and using 50 now. Or if you don't want to do that, you can put 40 where its alternate interior angle would be, down near his friend. Just figure out what you're going to do right now. Okay, put the 50 in or put the 40 in. It's up to you. And then from here, what's the 16? I'm sorry, I don't want to say 16 because you're not using 16. Where's the opposite side? Where's the adjacent side? So you guys go ahead right now. This stuff I'm not going to call on people or help you out with here. You guys got to figure out what you're going to use. What am I going to use? I'm going to use the 50. I'm going to use the adjacent angle. No matter if you use 50 or the alternate interior angle of 40, you should still be using tangent. Everyone should be using tangent. It's just a matter of whether you're going to put 50 or 40 next. And you shouldn't be using 16 or 1.8 in your ratio. You should be using 17.8. All right, so make sure you have 17.8 in there. Whether it's adjacent or opposite, you should have 17.8. Cross multiply. Nothing to add on or subtract here at the end because you're finding a full side. So we're good, we can round. $21.2. Any issues at home? Ask away. Any issues here in class? We good? 21.2.
Wait, I didn't get that. I did like the other. Oh wait, never mind. I found the problem.
Okay, no problem, Dave. Anybody else? All right, another depression one coming up. Now we got a lighthouse looking down on a boat. Angle of depression of 20 degrees. I'll still help you guys out here. This is our second one. I remember from the lighthouse, horizontal distance, and then looking down to the lighthouse. There's my angle. That's how the 20 degrees was created. Again, not inside the triangle, so you guys are going to have to figure out what you want to do with the 20 to get it inside. But you can at least see your right triangle that you're working with here. The lighthouse, 28 meters tall. The cliff, 45 meters tall. And everyone reading the question carefully, what is the horizontal distance between the lighthouse and the ship? So we should not be finding the hypotenuse here, right? Because we're finding the horizontal distance. So it's the horizontal leg we're looking for. I'm going to change that in the next problem, but for right now, it's the horizontal distance. And again, tangent it is, no matter if you're using 70 or you're using 20. Should be tangent again. And we should be using 73, I get that? Yeah, 73 as your adjacent or opposite side.
I have a question.
Yeah, go ahead.
If you use the alternate interior angle,
Yep.
wouldn't it be opposite?
No, I'm saying it's either opposite or
Oh,
adjacent.
okay.
Yes, 73 should be in your ratio, whether it's adjacent or opposite. Yep. And we don't need to add or subtract anything here. Nearest tenth. Watch your rounding. Watch your rounding. You should just be happy it's not simplest radical form, right? We can deal with rounding. And then 200.6 meters. Anything I can answer from you guys at home here? Because now you're going to have to do your own diagram.
I think I did something wrong.
So you got tangent of 20.
Wait, why would it be tangent though? Because wait, never mind. I messed that up.
Okay, all right.
I was,
Anybody else? All right. Up next, a blank slate. Angle of elevation. So everyone knows we're looking horizontally up now. Horizontally up from a control tower. Oh boy. Now we all get to see our artistic ability, huh? This should be good. Oh God, here we go. I'm embarrassing. I'm just going to admit it. I'm sorry. Control tower. Or a mushroom, whatever. Okay, whatever. All right, whatever you guys got. Okay, that's good. I'm throwing myself out there. All right, no self-respect. I know. That's why I'm in the math department, not the art department. So we got a plane going. So let's get that angle of elevation drawn right now. So horizontally coming from the control tower up to the plane makes a 7-degree angle. Okay, 7-degree angle. Now, here's one thing. It's not a math vocabulary term, kind of a vocabulary term with airplanes. The tower's 200 feet tall. All right, so let's get that down. The tower's 200 feet. The altitude of the plane is 5,200. An altitude of a plane is if you're standing on the ground looking directly above you, that's how far the plane is above you, is the altitude. All right, so from the ground to the plane right now is 5,200 feet. That's what it means by altitude. All right, directly above you, 5,200, directly above you. All right, so you see the right triangle that we can make. All right, here's the thing I need you to focus in on because I changed the direction from last problem. How far away is the tower from the plane? Not like I did in the last problem. What is the horizontal distance? Now what I'm looking for, I drop the word horizontal, tower to the plane. Boom, right there. Tower to the plane. Now I'm looking for the hypotenuse. If I want the horizontal distance, guys, you know what? I'll write that darn word in. All right, but now I want tower to plane directly. If I want the horizontal distance, just like I did in the last problem, I will write that word in. So there is no confusion. All right, sorry I had to get fired up about that. Just want to make a point. Oh, whoa. I don't know another side length. I got X. Anybody help me with another side of this triangle? What's up, Radhika?
subtract the altitude from the height of the control tower.
5,200 minus the 200 height of the tower. I know this side's got to be 5,000. Yep. All right. You guys figure out sine, cosine, tangent here. What's the 5,000? What's the distance from the tower to the plane represent? Is that hypotenuse, opposite, adjacent? Hopefully we're all in agreement where we should all be using the sine ratio here, because you have opposite 5,000, hypotenuse x. So we should be using the sine ratio. Sine of 7, opposite 5,000 over x. So hopefully now you're dividing both sides by the sine of 7 to get x by itself. Dividing both sides by the sine of 7. And round your answer to the nearest foot. My diagram was in feet, so we're all good. (41,027 feet from the control tower to the plane. Again, if I'm looking for the horizontal distance, I'll plug that in for you.
Would it be 28 because it was 41,027.5?
Was it?
Yeah, I think that's right.
I definitely could have just read that wrong, yeah. And yes, it is. So 28, one job. Round correctly. Thank you. So let's try 28 instead. There we go. All right, anything else? Because that was our last elevation depression problem for today. Last one has to do with quadrilaterals, going back to that unit. We're all confident we can draw a good angle of elevation and a good angle of depression. Just a reminder, depression, you got to figure out if you're going to do the complementary angle or the alternate interior. All right, let's finish here. Let's finish. Let's go back to our boy or girl, the rhombus here. A, B, C, D, clockwise, counterclockwise, label it. Don't jump diagonally on me. Label it clockwise or counterclockwise. A, B, C, D. All right, let's go diagonal AC. Let's draw in diagonal AC. That's going to be 80. You can put 80 on there. I know it's coming up, so I'm going to leave the 80 off. You can throw 80 on there. And angle BAC, 42 degrees, kids, 42 degrees. All right, what's the length of the other diagonal, BD? They're not congruent. That's in a rectangle, not a rhombus. They are not congruent, so just don't tell me it's 80. What is the length of diagonal BD? All right, start dishing out properties of a rhombus that may help me here. Any properties you remember from a rhombus that may help me? Radhika, go ahead.
In a rhombus, opposite sides are parallel because it's a parallelogram.
Okay, opposite sides are parallel, so if you want to say that's 42, that's going to be 42, right? Because they're alternate interior. All right, let's keep going. Other properties here, because I am not confident right now that I can figure out what that other diagonal is, just knowing this information.
The sides are equivalent?
All sides are equal, yep. So you find one side, you find them all. Good. All right, I still need more. I think you guys would agree. That's not going to give me the diagonal BD yet. Still grinding. Let's go. What other properties of a rhombus? And remember, we drew the diagonals in for a reason. So why don't we talk about the diagonals? Properties of a rhombus and their diagonals.
Bisect each other.
They bisect each other. Okay, so wait a second. So AC was 80. If they bisect each other, okay, so this is going to be 40 and 40, right? Ooh, we're getting there. We're getting there. I see 40. I see a 42 degree angle. There's one big property we're missing that's going to help us. Hannah. In a rhombus, the diagonals are perpendicular. That is the key that's going to combine all of this together here. Yes, so you have a right angle here and on the other three angles as well. Hey, look what we just created. A right triangle, didn't we? We have a right triangle. I know an acute angle is 42. One side's 40. So let's make a plan, because after this plan, I'm taking my hands off and you guys are going on your own. I can't find diagonal BD using that right triangle, but can I find this leg? And then do what with it if they bisect each other to find all of diagonal BD? What could be my plan? Find that leg and do what with it to find diagonal BD? Double it. Multiply it by 2 because they bisect each other. So I'm done. I'm done right now. You guys are figuring out part A and B now. You see the right triangle we created. We just went over how to figure out how to find diagonal BD. Find half of it and then double it by using sine, cosine, tangent. And then you guys can figure out how to find a side on your own. I am just going to write what you should get and then see if you can get there. Diagonal BD, you should get as 72, has a length of 72. Get there. And then part B, one side of the rhombus is 54 units. Get there. If you cannot get there, call me. All right? Let me know where you're having trouble if you can't get to 72 and 54. If you finish before we're done, move on to the homework pages. Move on to the homework pages. 72 and 54 you should get to. You can get there.
What do you want us to round to at the end?
Is there a integer? So that means whole number.
Oh, yeah.
Yep, integer, whole number.
So what I tried doing for part B was, because we had the other 42-degree angle in there, I was going to take the diagonal that equals 80,
Okay.
and I'm going to try using
But there's
midpoints as a tangent.
but the problem is there's no triangle that's a right triangle that has 80 as a side, right?
Yeah.
You have to use one of the four right triangles inside. I see what you're trying to do. If that was a rectangle, I would completely agree. All right, but B, C, A, and D are not right angles.